this video, we'll be looking at Chapter 8, Radical Expressions and Sequences. So we're going to look at square root functions to begin. So our essential question for today will be, how do I evaluate and graph square root functions? How do I evaluate and graph square root functions? Before we begin, we're going to need some definitions. So the first definition we'll use is radical. Radical is the root symbol. And then we'll need radicand is the expression under the radical. For example, if I have the square root of 4x plus 3 minus 2, 4x plus 3 is the radicand. It's the expression that's underneath the radical. Okay. Now that we have those definitions, let's dive in. So I have the square root of 64. 64 is my radicand underneath my radical symbol. So when I think of the square root, I'm trying to find a number that multiplies by itself to equal 64. Well, we have 8. But there's another number that can do that as well. What number multiplied by itself equals 64? Well, we could have negative 8. And the way you might see this written is, since I have one that's positive and one that's negative, you'll see this symbol, which translate to plus or minus 8. So when we read the plus and minus sign, we read it as plus or minus 8. So we're thinking of it as both positive and negative. So when we have a negative out front, it really doesn't affect the result, because a negative out front would mean that I still have the square root of 6. So I'd have the negative out front, that's that right here. And the square root of 36 would be plus or minus 6. What's the opposite of plus 6? That's going to be a negative 6. And what's the opposite of negative 6? Well, that'll be a positive 6. So we still end up with plus or minus 6. And 3 already has our plus or minus on the outside, so it's essentially the same exact kind of process. If I had plus or minus 7, what's that going to do? Not much. It kind of keeps everything the same, so we can just say plus or minus 7. Now 4 is interesting in the fact that when we really put some thought into it, there's no two exactly the same numbers. There's two numbers that are exactly the same that I multiply to get negative 4. The only way to multiply to get negative 4 is to go 2 times negative 2 is equal to negative 4. And these numbers are not the same. 2 times negative 2 equals negative 4, but these numbers are not exactly the same. So when there are no numbers that can multiply together, so essentially anytime there's a negative underneath the radical, we will say that there's no solution, no real solution. All because of the negative underneath the radical. Okay, on number 5, we are going to find we're just going to evaluate. These are pretty straightforward. We're just, since this says f of x equals 3 times the square root of x plus 21, find f of 4. Remember, that just tells me to take that 4 and plug it in for x. So I will say f of 4 is equal to 3 times the square root of 4 plus 21. I'm just simply replacing the x with the 4. And now I simplify, and I'll say f of 4 is equal to 3 times the square root of 25. We're simplifying. F of 4 is equal to 3 times 5. Square root of 25 is 5. And then 3 times 5 is 15. So we found that f of 4 is equal to 15. Now, something we have to be very mindful of, and I see this mistake happen a lot, is make sure you know what is underneath the radical and what's on the outside of the radical. This minus 2 is on the outside of the radical. So we will apply the square root first before we think about this subtracting 2. So let's evaluate this one. So I have y is equal to 3 times the square root of 9 minus 2. So I'm going to do the square root first, then my multiplication, and then my subtraction. So y is equal to 3 times square root of 9 is 3, minus 2, and then we have y is equal to 9 minus 2, which is equal to 7. Okay, so let's move on to the domain. So this is when, if I want to just talk about all the possible x values. So to find the domain being our x values, set the radicand. Radicand is that expression under the radical. Set the radicand greater than or equal to 0 and solve for x. So let's look at number 7 and do that. So if I'm finding the domain, I set that radicand. That's that 2x underneath the radical. I'll set that 2x greater than or equal to 0. Then I divide both sides by 2, and I get x is greater than or equal to 0. There is my domain. X is greater than or equal to 0. So we're going to do that just about every time if we're looking for the domain. We take that radicand, that expression underneath the radical, set it greater than or equal to 0, and then we solve for x. To find the range, take the x value found from the domain, plug in, solve for y. And then we have two cases. 1, y is greater than or equal to the result if the radical is positive. Case number 2, y is less than or equal to the result. This blank is representing the result from finding that range value. If the radical is negative. Okay, so let's look at the range on number 7. So I'm going to take this x value and plug it in and solve for y. So I'll say y is equal, oh, let's write range. So I'll say y is equal to the square root of 2 times plugging in that x value of 0. So I'm plugging in my 0 right here, and then add 3. So y is equal to the square root of 0 plus 3. The square root of 0 is 0. So I have y is equal to 0 plus 3 equals 3. So I found y is equal to 3. Now, since my radical, there's no negative in front of my radical, no negative number, it's a positive. So I'm going to use case 1 because my radical is positive. So I will say the range is y is greater than or equal to 3. I took the 3 from simplifying for y, plug in my x, found what y equals, and then since my radical is positive, I'm going to use the greater than or equal to sign. Okay, so let's try this with number 8. We'll take the domain that's taking that argument, the expression underneath the radical, and setting it greater than or equal to 0. So I'll say x minus 4 is greater than or equal to 0. We add 4 to both sides, and we have x is greater than or equal to 4. There's my domain. Now to find the range, I plug this x value in. Just like on this one, that 0 got plugged into our equation, I'm plugging the 4 into our equation. So I'll have y is equal to 1 plus the square root of 4 minus 4. So y is equal to 1 plus the square root of 0. Y is equal to 1. Now I can say the range is all this is correct. I'm just going to change the color real quick. There we go. So now I can say the range is y. Now is y going to be greater than or equal to or less than or equal to? Well, my radical is positive. There's no negative in front of it, so I'll use greater than or equal to. And then that value that I found right here, 1. Like that. So that's how we can find the domain and range. So I'm going to stop this video right here, and then I'm going to split this lesson into two videos, but I want you to do both of them over this weekend. So go ahead and stop the video right here, or this will be the end of this video, and then please do the next video before our next class meets. So thank you for watching this video, and I hope you have a great rest of your day.